Today we are going to learn algebraic expressions. Phrases made up of constants, variables, along with mathematical operations are called algebraic expressions. Examples: 3x m squared half n add 6, 4x squared plus 2x minus 5, 2a add 3b minus c are some examples of algebraic expressions. Write the following as algebraic expressions. Twice a number. Twice a number. If we consider the number to be, say, represent number by letter x, then we have to write it as 2x. We can use any other letter. So we could say 2n. The sum of two different numbers. Sum means the answer to adding two different numbers. So if we consider numbers, represent them by letters a and b, then we have a add b is the sum of the two different numbers. Difference of two numbers. If we take numbers or represent them by x and y, then the difference will be x minus y. Same thing, sum of a number and 10. If we consider the number to be n, all we need to do is to add 10. The quotient of a number and 3. Quotient is the answer to division. So if we take the number to be m, we then divide it by 3. That is the quotient of a number and 3. Or we could write that as a fraction m over 3. The product of a number and 7. Product is times. So we have 7 times a number, say t. Or we can write it as 7t. Now try exercise 1. Substitution. Evaluation of algebraic expressions. Given that x equals 5, work out the values of I, 3x add 10. This means 3 times the number add 10, but we are given the number to be 5, so we have to then substitute the 5 in terms of the x. So we replace this x here by 5, then add 10. So the first thing to do is to do the substitution before doing any working out. So we have 3 times 5 is 15, then we add our 10 to give us 25. The next one, 5x minus 3, meaning 5 times a number minus 3. So we're going to have 5 times, what number we're talking about? 5. So we put the 5 here and minus 3. That gives us 25 minus 3 to equal 22. Next one is 18 minus twice a number. So we have 18 minus twice a number, and the number here is 5. So we're going to get 18 minus 10 to give us 8. Given that a is 2, b is 3, and c is 7, evaluate the following expressions. C is 7, b is 3. So we're going to have a add b will therefore be a is 2, we're going to get 2 add, and b is 3. We add 3 to give us 5. Next one, twice a, so we have 2, our a is 2, add 5 times b, our b is 3, minus 3 times c, our c is 7. So this will give us 4 add 15 minus 21. That is 19 minus 21 to be equal to equals to minus 2. C. 2ac means twice 2 times a times c. So we have 2, our a is 2, our c is 7. So we're going to get 2 times 2 is 4, 4 times 7 to give us 28. B at C, our B is over there 3, our C is 7, we divide that by 2. So that will be equal to 10 over 2 to be 5. Work out the value of 1 over n into n plus 1 for n equals 2. So we have for n equals 3. So we're going to have 1 over 3 into 3 add 1. That will be equal to 1 over 3 into 4 to get 1 over 12. You don't need to do anything, you leave it this way because a fraction is a number. Try exercise 2. Addition and subtraction of algebraic expressions. An expression such as x squared add 3x minus 8 can be split up into 3 different components. X squared, positive 3x, and minus 8. These together are called terms. Hence, this expression has got 3 terms. Like and unlike terms. X and 5x are like terms. However, x and 5x squared are unlike terms. These are like terms because they have the same variable and of the same power, no exponent. It's just x and this is just x. This is x and this is 5 of the same x's. But these are unlike because this is x and that is not just x but x squared. X, 1x here, but this is 5x squared, so they are not like terms. Other examples can be x squared and maybe 11x squared are like terms. 5a and 17a are like terms. But y squared and y cubed are not. A and b are unlike terms. In maths, expressions with more than one term can be simplified if they contain like terms. So, example, 5x add 8x can be simplified because they have like terms. 5x and 8x are like terms, so we add that to get 13x. 5v minus 6v are like terms, so we can subtract them to get 9v. Over here, we need to do what we call collect like terms. The like terms here, this is 5a and this is 2a, so we collect them to get 5a add 2a. Then we collect this base. The other like terms are 7b minus 3b. Before we simplify, so we then simplify this as 5a add 2a will give us 7a, and 7b minus 3b will give us 4b. So we have simplified that. Next example, D. We have x squared and 3x squared are like terms, so we collect that to get x squared add 3x squared. This is alone, it is not like to anything, we just write it there, and this alone, this is a number. So the like terms here will give us 4 x squares, add, we're left with x and 2. That is done. Finally, for this one, we have 2p add 8z. Because they are unlike terms, we are done. They stay the same. You cannot simplify them. So our answer stays as 2p add 8z. Multiplication and division of monomials. Monomials means one term. So this have got this one term, this a term, and this another term. To multiply algebraic expressions, we start by multiplying the numbers, if there are numbers. So we have 5 times 3 to give us 15. Then we have our b. Over here we have 2 times 5 to give us 10, and x times x will give us x squared. Over here we have 3 times 3 will give us 3 times 7 will give us 21, and then x squared times x cubed will give us x to the power 5. Here we have 4 times 3 will be 12, 12 times 5 will be 60. Then we have our y, x, and m. In algebra, it's preferred to write them in order, so we have m, x, y. Division. The best way of dealing with division is to apply what we call cancelling down. So let's start with the numbers. What number goes into 6 and also into 9? 3. The number, the common highest common factor is 3. 3 here, 2, 3 here, 3. So in terms of the numbers, we are left with 3 over 2. Then the next common factors are the a cancels out a, one of the a's. So the a's are gone, we're only left with x. So our answer will be 3x over 2. F. The numbers again, 5 here 1, 5 here 2. So in terms of number, we're left with only 2. A cancels out 1a, and we have no more a's. There is no b up here, and there is no b. There's b down, so that nothing can cancel. We'll be left with c, y as a numerator, and then b as a denominator. The best way of dealing with this is to write it as a fraction. So we have that to be x, 3x y over 12x y z. The numbers will cancel out. 3 here, 1, 3 here, 4. So we have 1 quarter. 1x cancels out 1x, 1y cancels out 1y. So the numerator is left, is only 1 left there, and the denominator is got z left. So we have 1 over 4z. H. I repeat this bit. Sorry, let me go over here. I'm going to go over this one again. We write first as a fraction, so we have 3 over 3xy all over 12xyz. 3 here, 1, 3 here, 4. X cancels out x, one of the y's cancels out one of the y. So we'll be left with only 1 as a numerator, and then denominator we have 4 and z. So we have 4z, yeah, that is it. Next one, the common factor here, 8 and 12 is 4. 4 here 2, 4 here 3. So we are left with 3 numerator, and then 2 a denominator in terms of numbers. The a's. One of the a's will cancel one of them here, so we're left with only 1a. And there is no common factor in the numerator and denominator. So we'll have b, c. try exercise 3. Expanding brackets. To expand brackets, all you need to do is to multiply out each of the terms inside the bracket by the term outside the bracket. So in this case we have 4 outside, so we multiply 4 by x to give us 4x and 4 by 5 to give us 20. Next one, 5 times 3x will give us 15x, and then 5 times 7 will be 35. Over here we have x times x will give us x squared, and x times minus it will give us minus 6x. P times p will give us, p times 5p will give us 5p squared, and p times minus 7 will give us minus 7p. 8x times x will give us 8x squared. Add 8x times 2 will give us 16x. Over here, 5x times 4y will give us, the numbers will multiply to give 20, and this will be x, y. 5x times 3 will give us 15x. Over here, we have x times 2x squared will give us 2x cubed, and then x times minus 5x will give us minus 5x squared, and then x times positive 7 will give us positive 7x. 8 minus 2 times 2x will give us minus 4x. Minus 2 times minus 5b will give us plus 10b. Minus 2 times positive 7 will give us minus 14. Minus 5x times 11y will give us minus 55xy. Minus 5x times minus 2 will give us plus 10x, and minus 5x minus 4x will give us plus 20, minus 4t will give us plus 20xt. Now, this question is just to let you understand that the variable can sometimes be on the right hand side, because in the previous case we have them on the left hand side. We just apply the same principle. We apply whatever is outside the bracket by each term in the bracket. We have t times 3t will give us 3t squared, and then t times minus 5 will give us minus 5t. Here we do the brackets first, so we leave the 3x as it is and expand that bit. So 5 times x will give us 5x, 5 times 2 will give us 10. We leave the 5x here, then expand this bit. This is minus 7. Don't work it as 7, consider it as minus 7, because that is what it is. We have minus 7 times x will give us minus 7x, and minus 7 times 2 will give us minus 14. Now in this case, you have to do something about it, because they are like terms. We have to simplify. So I'll go back to here, because this is 3x and that is 8 and 5x. They will simplify to give us 8x. So the best way to leave it is 8x as 10. The same way, here is 5x minus 7x will give us minus 2x. Then we have our minus 14. So note, wherever there are like terms, you need to simplify. We have 11x minus 5 times x will give us minus 5x, and the minus 5 times minus 1 will give us positive 5. Again, we simplify this to give us 6x, add 5. Here, we do the bracket to give us 2x, add 20, before we subtract our 9. So we're going to get 2x, add 11. Try exercise 14, exercise 4, please. Visit my website for further videos and exercises. Thank you.